So in this video, we are going to learn how to solve different types of inequalities using a sign chart. All right, so this is a really good technique when you're solving any kind of an inequality other than a linear one, which you've learned in Algebra 1. So we're going to run through a couple different types of functions, eventually leading to a rational function, which is what we're studying in this unit. All right, so I'm going to call this part 1, okay? Just in case you just need half of the video, I'm going to kind of give you a good starting point. So the first day we talked about in part 1, which is how to create / use a sign chart, okay? So kind of bubble this in right here. Here's the directions for example 1. For example 1, what we're going to do is you need to determine the values of x that cause the function, which will be given below, okay, to be part A, 0, part B, positive, and part C, negative. Okay? So we're not quite solving yet. We're just going to practice using the sign chart idea to determine where the function is 0, positive, and negative. We'll make sense out of all of this. Okay? So for part A, we're going to use the function f of x equals x plus 4 times x plus 1 times x minus 5. Okay? So what we have here is a polynomial function, which I can tell if I multiplied all the factors would be a third degree. So the first thing that we're going to do is we need to determine the roots. We need to determine all the place where the function equals 0, which is why they call it the zeros. So first, what we're going to do is we are going to find the zeros, which is going to answer part A. So to find the zeros, we're going to set each factor equal to 0, which this is conveniently in factored form. If it was not in factored form, that's the first thing that I would do, is I would probably try to factor it, or I'd have to find the zeros in a different way. So the zeros are going to be x equals -4, x equals -1, and x equals 5. And so what we're going to do here is we're going to create the sign chart, which is going to look like a big number line, okay? So sometimes you'll see in textbooks a sign chart is an actual chart or table. I like this method a little bit better, so that's why it's called a sign chart, even though I'm using a number line. And so what we're going to do first is we're going to put our zeros in, which is -4. All right, so we've got... Hold on, sorry about that. When I hit a letter, it won't let me type. All right, we've got -4, -1, and 5. And I'm going to use closed circles on all of these because this is where the function is equal to 0. All right, this is basically where the function is going to cross the x-axis, which is why they're the zeros. So for part A, I would say the answer is -4, -1, and 5. Okay, but we'll come back to that. Now what we need to do is we are going to determine where the function is positive and negative. So what we're going to do is we're going to use a test point, okay? Let me scroll down here so we can see this. So let's say in this interval, I want you to pick a number that's somewhere in this interval. So basically pick any number in this interval. It could be -5, -6, -7. I don't necessarily care, so I'm going to go ahead and I'm going to try -10. All right, I kind of like to exaggerate it a little bit and go further out than the -4 because it makes it really clear if it's going to be positive or negative. And what we're going to do is we're going to plug -10 into all the different factors. All right, so if I plug -10, and so basically when I plug -10 into 4, the result is negative. And this is what's interesting with it, is people, in my opinion, they get too nitty-gritty with the arithmetic. And the whole point of it is to figure out if the interval is positive or negative. Well, all I need to know about this first factor right here is that when I plug in -10, the result is going to be a negative. And in fact, the result's going to be negative for any value in this region that you plug in. So it doesn't really matter if I pick -10 and someone else picks -6, for example. All right. So that first factor, no matter what, is going to be a negative. Now we're going to plug negative 10 into this factor. And again, if you want to say to yourself negative 10 plus 1 is negative 9, that's great. But the important part is that the second factor is going to always be a negative. Finally, then, I plug negative 10 into here, and I can quickly see that if I plug a negative 10 in for x, negative 10 minus 5, the result is going to be negative. So here's the question. What happens when we multiply a negative times a negative times a negative? Well, what happens when you multiply three negatives? The result is going to be a negative. Okay, so it's interesting that we can figure out if these intervals are positive or negative just by knowing the sign of the factor. We don't actually have to know the numbers and do the arithmetic. Because, by the way, these questions are going to be no calculator. So let's not even bring the calculator into this. So, all right, if that was a little bit confusing, stay with me here. Let's try our next interval. Our next interval is going to be between negative 4 and negative 1. You can pick any number you want, okay, between negative 4 and negative 1. So there's a little bit of flexibility here. So let's suppose I try negative 2, okay, just kind of like right in the middle. So what I'm going to do this time is I'm going to plug a negative 2 into my three factors. So if we plug in negative 2 plus 4, the result is a positive. Okay, whether or not you want to do the arithmetic of negative 2 plus 4, it's obvious that it's going to be a positive, and that's what I care about. This is negative 2 plus 1. Well, in this case, the result is a negative for this middle factor. And here, we are going to plug in negative 2 and subtract 5, which I can quickly see that that result is going to be a negative. So what happens when we multiply a positive times a negative times a negative? Well, anytime we multiply two negatives, the result is going to end up being a positive. So what we're saying is any number that you plug in between negative 1 and, now you can't plug in negative 1 and you can't plug in negative 4 because that makes the function equal 0. You have to plug in a number inside the interval, and any number you plug inside this interval, the outcome will always be a positive. All right, so let's keep going and see if we can continue to make sense out of this. My next interval right here is going to be between negative 1 and 5. Well, anytime I have an interval where I go from a negative to a positive, I always try to take advantage of using 0 because it's pretty easy to see. So let me erase my previous work up here. And now what we're going to do is we're going to plug a 0 into my three factors. So 0 plus 4 is going to be a positive. 0 plus 1 is going to be a positive. But here, 0 minus 5 is going to be a negative. And when I multiply a positive times a positive times a negative, the result is going to be a negative. All right? So we got one more interval to go. We're going to pick any number greater than 5. So let's say we were to try x equals 100, okay? That's the thing. It doesn't really make a difference as long as you pick a number that's bigger than 5. So we've got our three factors right here. Well, obviously 100 plus 4 is a positive, and 100 plus 1 is a positive, and 100 minus 5 is going to be a positive. And when we multiply three positives, we know that the result has got to be a positive, okay? So I would know that this last interval is going to be positive. So let's come back and let's now answer the question. For part A, where does the function equal 0? When x is equal to negative 4, equal to negative 1, and equal to 5. That is where the function equals 0. For part B, where is the function positive? Now, the definition of positive is greater than 0, does not include 0. So the positive intervals are going to be between negative 4 and negative 1, which I am going to use parentheses because we need to exclude the 2 points where it equals 0. And then the next interval where it's positive is when it's greater than 5. So union 5 to infinity. All right, and then for our last interval, we are going to state where the function is negative, and negative by definition is less than 0. So again, it does not include the zeros. So it is negative from negative infinity to negative 4. And then it is negative between negative 1 and 5. So that is the general idea of how to use a sign chart. Now in part 2 of the video, I'm going to show you how to use this sign chart concept to solve inequalities. Okay, but for now, we're just getting good at using a sign chart. And really, I do this connection in class. I'm just going to show you really quick. But what we're doing here, let me get my work out of the way. What sign charts can also be used for and how they were used a long time ago before calculators is you could do some early curve sketching. And I always like to do this just so that you know what it is we're doing when we say positive and negative. Well, what's going to happen is negative means the function is below the x-axis and at negative 4 it crosses. And then it comes up and it has to come back down to hit negative 1, which means there must be some sort of a maximum that occurs between negative 4 and negative 1. And then the function's going to come down, but because it needs to curve back up to cross again, this means it's going to hit some sort of a minimum. And then it's positive to infinity, so that means that the function is going to go up forever. So that's what we mean when we talk about negative and positive is negative is where the function is below the x-axis and positive is where it's above the x-axis. And we can figure out all these intervals without actually having to look at the graph, which is pretty cool. All right, so let's do our second example with a sign chart. And this time our function is going to be a rational function, which means we are going to put a polynomial in the numerator and in the denominator. And let's see how we would work out this sign chart. So first thing I'm going to do is I'm going to rewrite this in factored form, and that squared there means that I have 2x plus 5s, but I actually like it better with being x plus 5 squared, and obviously this is going to factor into x plus 3, x minus 3. So it just kind of depends on what I'm doing, on whether I want to look at standard or I want to look at factored. So let's go ahead and let's start by finding the roots, okay? Or let me call it the zeros so that makes part A make more sense. All right, well, the zeros of a rational function are in the numerator. So we would take this part right here and say that x plus 5 is equal to 0. Well, that means that x equals negative 5 is the 0. Now, yes, that is a multiplicity of 2, and we'll look later and see in this sign chart what implication that has. But for now, we just know that there's some sort of a 0 at x equals negative 5. And I apologize. I'm just scooting this up so I make sure that I have enough room. All right, so x equals negative 5 is where the function equals 0. So let's go ahead and set up our sign chart and make a big number line. Oh, I know what we needed to do. I knew I was forgetting something. We need to figure out where the function is undefined because of our red flags, and we have to look at the denominator. Well, what we see is that x plus 3 cannot equal 0 and x minus 3 cannot equal 0. So there are two undefined points at negative 3 and 3. So let's tie all of this together. At negative 5, I'm going to use a closed circle because this is where the function equals 0. At negative 3, I'm going to use an open circle because this is where the function is undefined. And at positive 3, I'm going to use an open circle because this is where the function is undefined. All right. Now what our goal is to figure out what's going on between the zeros and the undefined points. And we do that by figuring out if it's positive or negative. So for this first interval, pick any number, and I am going to try x equals negative 30, okay? And I'm purposely picking something kind of exaggerating just so you can see that I really do not need a calculator when I do this. So the first factor up top, and we've got a factor, and we've got two factors on the bottom, okay? So let's plug in negative 30 and see how this is going to go. So this is going to become negative 30 plus 5, and we're going to square it. Now here's what's interesting. I'm going to get a negative, and I'm going to square it. And I really don't care if I have a negative in this parenthesis or a positive in this parenthesis. The result is always going to be equal to a positive. And so what's kind of nice with this is I know that this top factor, I'm going to make a little note right here, this top factor is always positive because anything squared is equal to a positive. The only thing that breaks that rule are imaginary numbers, but we are not putting imaginary numbers on our number line anyway, okay? So let's go ahead and let's plug in -3, let's plug in -30 into these bottom two factors. Well, obviously -30 plus 3 is a negative, and obviously -30 minus 3 is a negative. So actually, sometimes by over-exaggerating the x that you plug in, it makes it even easier to see if it's positive or negative. Well, I know that if I take a positive and I divide by two negatives right here, I know that the result is always going to be a positive, okay? So now what we're going to do is let's try this interval between -5 and -3. So let's suppose that we try x equals -4, okay? So we've got our numerator and two factors in the denominator that we need to look at. Well, we've already talked about how because of the squared, the numerator is always positive. So it's kind of nice as we don't need to keep plugging things into that numerator factor. Well, if we take -4 plus 3, we're going to get a negative. And if we take -4 minus 3, we're going to get a negative. So again, when I take a positive divided by two negatives, those two negatives are going to become a positive. And it's interesting here that we did not have a sign change. And the reason that we did not have a sign change is because of that multiplicity. And when you have a multiplicity of -5, or I'm sorry, when you have an even multiplicity, the graph, remember when you have an even multiplicity, is going to touch the x-axis and keep going. And so it's going to be positive on one side, and then it's going to continue to be positive because even multiplicities don't cross the x-axis. So we're really starting to connect a lot of stuff right here. All right, next interval, between -3 and 3. So remember, any interval that goes between positive and negative, let's take advantage of that opportunity to use 0. And so let me make some more space. We've got the numerator, which we always know is positive because of the squared, and we've got the denominator. So 0 plus 3 is going to be a positive, and 0 minus 3 is going to be a negative. Well, I can tell that if we have one negative in this operation, that is enough to make the entire interval negative. Finally, last interval is going to be 3. So I'm going to try x equals 10. And we've got our numerator and two denominators. Well, 10 plus 3 is obviously going to be a positive, and 10 minus 3 is obviously going to be a positive too. So this last interval is going to be a positive. So now let's answer the question, and let's answer this part A, part B, part C. So where is the function equal to 0? It is equal to 0 at x equals -5 only, okay? Where is the function positive, which means greater than 0? Well, it's greater than 0 here, here, and here. Because we can't include the -5, because positive means greater than 0. We can't include the -5 because that equals 0. We're actually going to have 3 separate intervals: -infinity to -5, -5 to -3, and then finally from 3 to infinity. So for part C, where is the function negative? It's going to be this one interval right here between -3 and 3. All right, so that is the basics of how to use a sign chart. And what's going to follow this in your homework is to do numbers 1 through 10. And if you're continuing on to listen to part 2, then I'm going to show you how to use a sign chart to solve an inequality. So if you're continuing on, then let's go ahead and start part 2, which is solve inequalities using a sign chart. So the work is going to be pretty similar to what we were doing in the previous examples, but the answer this time is just going to be the solution and not part A, B, and C, where we give the positive and negative. So I'm just going to do one example for this, example 2, and we are going to solve this rational inequality. All right, well, we can't solve for x, okay? We can't find our zeros until I add the fractions, and we can't add the fractions until I get a common denominator. So for our first step here, I'm just going to copy down the problem. We need a common denominator, and the common denominator is going to be actually both the factors. So I'm going to multiply this side by x minus 1 in the numerator and denominator, and I'm going to multiply this by x plus 3 in the numerator and the denominator, and I'm going to remember that this is greater than or equal to 0. And in fact, this is a good time to talk about what this means right here, because at the end, a lot of times students do all the work for the sign chart, and then they don't know how to answer the final solution. What greater than or equal to 0 means, so I'm going to put this in words. This is greater than or equal to 0. And I know that might seem pretty obvious, but what that means is we need to give all the positive intervals, and we need to give where x equals 0. So this is what we need to state in our solution, are all of the positive intervals and where x equals 0 because of that extra equal to right there. All right, so let's go ahead and continue on with our common denominator. So this is going to be 5 times x minus 1. You know what, I'm going to actually do this. Let's just go ahead and distribute just so we can kind of condense some steps. This numerator is 5x minus 5 over the common denominator. And this numerator is 3x plus 9 over the common denominator. And again, the point of the problem is to condense this to a single fraction with a common denominator where we can simplify the like terms. 5x plus 3x is going to give us 8x, and then we get that negative 5 plus 9 is going to be plus 4. All right, so there is our numerator and our denominator. So we always want to get 0 on this side, and on this side that I'm looking at, let me highlight, this side we want to get to be a single fraction, okay? So now let's continue on with our sign chart. And the first thing that we do with the sign chart is we need to figure out where the zeros are. Well, the zeros occur in the numerator. So let's set this factor equal to 0, okay? And I notice that I don't have any holes. That's the only thing you got to be careful of is, if I factor this out, I don't have a repeating factor. Just be careful with the numerator, because if that factor occurs in the numerator and the denominator, it's undefined. So we got 8x equals negative 4, x equals negative 1/2 is the 0. And then we've got our undefined points. And our undefined points are going to be those red flags. X plus 3 can't equal 0, and x minus 1. So x cannot equal negative 3, and x cannot equal 1. So we take all of this, put it together, and we start building our sign chart. All right, so I see a negative 3 with an open circle because this is where the function is undefined. It will actually end up being a vertical asymptote. And then I see negative 1/2, and I'm going to use a closed circle because this is where the function equals 0. And then finally, we see a 1.
Sorry, I'm having...
And that's where the function, again, is undefined. So for all the intervals in between, this is where we're going to figure out if it's a positive or negative. So let's start with this first interval right here. And I try any number less than negative 3. So I'm going to try x equals negative 10, okay? So we've got a numerator and 2 denominator factors that we're going to plug in negative 10. So let's see here. Let's do a little bit. See, we don't even really need to do that much mental math, because when I take 8 times negative 10, I get negative 80 plus 4. That's enough for me to know that this is going to be a negative. Okay, when I plug in negative 10 plus 3, it's a negative. And negative 10 minus 1 is a negative. So what do we get if we take a negative divided by 2 negatives? Well, if there's an odd number of negatives, the result is going to be negative. So Let's move on to our next interval. And at any point, if this is starting to get kind of redundant, you can absolutely like pause the video, try some more of these intervals, and then go back and watch it. You know, fast forward, but go back and watch it and see if you're doing it right. Because you're right, because it does get a little bit redundant because we are doing the same thing over and over. So in this interval, let's suppose that we try x equals -2. All right, so we've got our numerator and two denominator factors. So if I plug in -2, 8 times -2 plus 4 is -16 plus 4. I have enough work to know that this is going to be a negative. -2 plus 3 is actually a positive, but -2 minus 1 is a negative. Well, what's going to happen if we divide by two negatives? The result is going to be positive. So this interval right here is going to be a positive. All right, and we continue on. And we've got this point, which again, if I ever go between negative and positive, I'm going to try x equals 0. So let's come back up. Let me erase some of my old work right here. And let's plug in a 0. Well, 8 times 0 is 0, so this is 0 plus 4. I feel pretty confident that top factor is a positive. Well, 0 plus 3 is a positive, but 0 minus 1 is a negative. So what happens when we take a positive? We've got two positives and one negative. The whole interval is going to end up being a negative. And then finally, we have our last interval, and I'm going to try x equals 9 just for something different. So I can pretty much tell that plugging in a 9 in the numerator is a positive, 9 plus 3 is a positive, 9 minus 1 is a positive, which makes this entire thing a positive. Okay, so let's answer this question again. And again, I'm only emphasizing this because this is where students get stuck, is they don't know after they do all of this, they don't know how to answer the question of where is x greater than or equal to 0. So I'm going to include all the positive intervals, including the -1/2, because I need to include where it equals 0. And then we've got a second positive interval right here. So the solution is going to be, all right, where is it greater than or equal to 0? And it's going to be from -3 to -1/2 with a bracket, and then from 1 to infinity. So your undefineds will always be brackets. Your equals 0 is going to depend on if there's an equal to 0. So if the inequality would have said greater than 0, then I would have swapped that bracket for a parenthesis. But if this says equal to 0, then that parenthesis becomes a bracket because we include it. Okay, so that's it. And there's still more to see and there's more to practice. But where we're going to go from here is you are going to finish the homework, which is that second section of the homework, starting with number 11. Okay, and thank you for watching.